Hello. In the first episode of Hotu002, I said that there were three predictions which had given rise to the theory of the Big Bang. The first was that the universe was expanding. The second was that the universe was filled with radiation. And the third was the ratio of atoms in the universe. In this episode, we're going to show how these predictions are supported by evidence. Imagine an observer standing near a stationary car whose engine is running. The sound from the engine is of normal pitch. Sound is a wave that travels through the air. Now imagine that the car moves. The sound from the engine is squashed up. The waves are closer together because you've got the velocity of the sound plus the velocity of the car. So we go from that wave to a slightly shorter wave. So the pitch of the sound is higher than it was before. Now imagine the car moves past the observer. The sound from the engine is stretched out because the velocity of the car is subtracted from the velocity of the sound. And so the pitch is lower. So as a car or other vehicle moves past you, the sound goes down. Something like that. Racing cars, you hear it especially. The Austrian physicist Christian Doppler suggested that the same effect should happen with stars. If a star moves towards the observer, then the light should be squashed together. Light is a wave. The wave should be squashed together and the light should look slightly bluer. We don't notice with a car because the velocity is so small, but stars can move very quickly, so the effect is noticeable. If a star moves away from the observer, the light is stretched out and it looks redder. So he predicted this change of colour, and in 1912 the American astronomer Slipher observed these changes. They're called red and blue shifts. And Slipher found something very strange. He found that red shifts were far more common than blue shifts, especially in stars contained in spiral clouds or nebulae. So, to prove that the whole universe is expanding, we need to be able to measure the distance of stars and show that the furthest stars are expanding the fastest. So, this confirmation of the predictions followed very quickly after Friedman and Lemaitre's predictions of an expanding universe. In 1929, the American astronomer Edwin Hubble used stars called Cepheid variables in order to calculate the distance of stars. Exactly how he did this is not interesting to us at the moment, but you can do it. He was able to calculate the distance of stars, and he found that the furthest galaxies, the furthest stars, now we know they're parts of distant galaxies, move away the fastest. The furthest stars, the furthest galaxies move away from us the fastest. That is the key point. It proves that the whole universe must be expanding. Because after all, if we observe this, we're nowhere special. We're not the centre of the universe. Everybody in the universe, anywhere, must observe the same thing. And therefore the whole universe must be expanding. The second observation, that the second prediction, that the universe was filled with uniform background radiation was quite difficult to measure, but it was finally found by Penzias and Wilson in 1964. And this is the cosmic microwave background radiation. The waves are very weak and they're in the microwave part of the spectrum. This is very important evidence supporting the Big Bang theory. The third prediction, which led to the Big Bang theory, discussed the abundance of the elements, and observations and new calculations confirm the predictions of alpha and gamma. We have found that hydrogen and helium are the most abundant atoms in the universe, and this confirms this fits in very well with the theory of a Big Bang, which began with very simple particles. We'll discuss the details soon in another video, and the simplest atoms were then created early on. So most matter was trapped in these simple atoms. The heavier atoms were created later in stars, and again we will discuss that in a separate video. It's worth mentioning about how science works. First of all, you make an observation of something around you. You then invent a theory. So science is an observational activity, but it's also creative. You have to think of an explanation of why can we see the things that we see. You then say, well, if my theory is correct, then what will happen if I do this? You make a prediction. The prediction it allows you to test your theory. You then do an experiment to test your prediction. And if your prediction is correct, then you have slightly more confidence in your theory. And if you do this many times, then your confidence grows until you are pretty sure that your theory is probably correct. However, you can always find a new observation which does not fit your theory. And then you have to start all over again. You're back to square one. You've made a new observation which doesn't fit, you've got no explanation, so you need a new theory. That is how science works. And that is what we've seen with the invention of the Big Bang theory. Notice that science does not deal with absolute truth. It deals only with theories. The theory is the best that we can have at any one time. So the current theory that the universe began with the Big Bang, we have lots of observations which confirm the theory, and we are pretty confident that this theory is correct. However, maybe one day we'll find something which doesn't fit. We'll have to think of a new theory. Thank you for watching.